Hello everybody, welcome back to From Rhythm to Algorithm Part 16, Contractions. We've literally built a new math subject. We've developed a sub-subject for that math subject. The subject being dimensionless analysis and the sub-subject being geometric linguistics. But what proving that logic does and proving the consistency of color does is it validates everything I'm saying. But it also gives us a new context to ask direct mathematical logical questions that you otherwise couldn't have asked, right? When you're bridging an ontology of mathematics, the proof of that is you can ask and answer new questions. We're just really picking up the conversation from where we left off last time. I keep saying that language is defined in complete generality, and I've also said that I don't personally understand. I'm forgetting something about completeness, but I wanted to demonstrate just what I mean, just some of the different facets of what I'm saying. So the sound E at the end of a word represents a generality, right, as represented by the letter Y. And you'll see this empirically in conversations all the time. When people are talking and conversing, they'll always extend the logic with the suffix ality. Say a word, put ality on the end, you're going to calculate its complete generality. But now to show, right, now we have it is what it is, just an empirical fact. People say it is what it is all of the time. No, I have never heard, nor have I ever spoken, it's what it's. And it's logically the same. It is what it is. It's what it's. So there's some logical facet there, but it's just a cool nuance. Again, no one says that, and it's evident because of contractions, right? And ing, right? I am contracts to I'm ing. But it is what it is the form of all logical reduction. Now, to define a new word, you have to draw a new analogy, right? We've shown that the word is represents a limit towards equality, like the equal sign, but it's not precise because of biological diversity. For languages in complete generality, right? I am. But there's 7.8 billion other people that will also use the sound I to reference themselves. And it's literally who's around who's each other, right? It's very clear who's talking about who. But this is to that what that is to this. That is the structure of all analogy. And analogies is how you define something by drawing a new relationship, right? We have a specialist, already defined in public conversation. It's someone who's localized, someone who's specialized, but it's someone who's unique, someone who can do something unique. So a specialist is unique, a sensorist is a generalist, someone who is generally good at something. We've also made the logical and linguistical distinction that sensorality with a C is reference to all non-sentient information processing systems. So I have sensorality with a C as a dictionary definition defined as non-sentient filters. Speciality, the tendency to differentiate, with the prepositional phrase for sexual antagonism. But I've shortened that just to speciality is the tendency to differentiate, right? A plant is not sexually reproductive. And then we've the sensorality with an S, right? The ability, and that is new linguistically, but logically, it is the ability to make sense. It is empirically proven by someone saying, anybody in complete generality, yeah, that makes sense. That is what you are validating. You're saying sensorality with your empirical value function is valid, is true, is correct. But that's what I wanted to point out there. And now developing this logic, we can just simply state a couple fundamental theorems that sound grandiose, but one does and the other one doesn't. But neither of them are complicated, and they're just true, right? What's the fundamental theorem of knowledge? A fundamental theorem is the most general statement you can make about a field of study. What is knowledge? I don't know. What is the fundamental theorem of knowledge? Well, whenever someone doesn't know what to say, or when they're not sure of what to say, they say the sound When they don't know what to say, they say the sound And that bridges the uncertainty principle from physics to the uncertainty principle of linguistics, or of knowledge, or of just some ape over there saying, See? But there, now we can just simply state the fundamental theorem of sound. The sound represents uncertainty. Facts. There it is again. But now, I also wanted to show how syllability begins to differentiate from sound and linguistics, right? It is what it is. I am Brad Boas. I live in Columbus, Ohio. The city, Columbus, Ohio. What's the difference between it and city, right? It's literally it, the consonant s, it, and then the sound e at the end of the word to make generality, right? But it's linguistically, it's a consonant sandwich of s, it, and e. And that just shows, again, evolving or expanding linguistic structure. Right, it, city, the sound is the same. Now how about it and item, right? It and item changes the pronunciation of the letter I, right? Just direct linguistical pronunciation examples of context defining a variable. And it's also, right, item is pronounced I-tum, like the word I and then T-U-M. How about it and orbit, right? Physics word, it, orbit, the orbit of Mars, the orbit of Earth. Now, again, those are facts, that's done. And now what reducing the proof of speciality, or reducing the proof of sensorality, showing the relationship of speciality and sensorality, what that will do is that will kind of introduce a new proofing mechanism, or just again demonstrate how to reduce words by how we already reduce reduce sound with contractions. And what I was going to say is we'll be able to formalize the reduction of logic, or the reduction of words to take any word and can you reduce it to another completely, let's just get an example. Right, what can be reduced to the sound wha and at. So how do words contract? How do we reduce sounds with letters? I don't know, but like I said, it will structure a new type of mathematical proof, logical reduction. I don't know. But the last thing I wanted to just demonstrate a couple more linguistic pronunciation things. They're definitely real. So we've rigorously demonstrated what the sound E at the end of a word does, but what does the sound E do at the beginning of a word? All right, my integration, mathematically, linguistically, it's iteration. So, what was I saying? Oh, how do we iterate the sound E through a word? And just some quick examples, right? E-A-S-Y, pronounce that word. Easy, right? It's literally the sound E separated by the consonant Z. E-Z. So, it just, again, that's the evidence. What's the proof? What's the reason? What's the reason why? And what does understanding the reason why, what formalization of mathematical proof can we produce from that? And again, we talked about axioms, efficiency. Not exactly sure if efficiency, like I said, I think in natural context, efficiency is not actually pronounced E at the beginning. But when does the letter E begin at the word,
but it isn't pronounced. The sound doesn't represent the sound E. Again, just direct evidential proof. That's what I wanted to cover in this episode. Thank you for watching. From Rhythm to Algorithm, Part 16, Contractions.